Hello class, so far we have been discussing about introductory concepts of Python programming. We used Python as an entry-level programming tool or language, and we have seen different syntax and structures, constructs of Python. This will be the last session, and on the other hand, the first session regarding the object-oriented programming. But it will be the last session for those who are attending entry-level Python programming with me. So today we'll talk about object-oriented programming practically, and the topics that I will be discussing are from object-oriented programming concept. We start from there. Then we talk about classes, okay? We talk about the specification nature of classes, the state class behavior characteristics of classes. Then we talk about object instantiation, instance methods, class methods, instance variables, class variables, and we talk about, the unique characteristics of object orientation in Python, which is inheritance and polymorphism. Since this is a very introductory concept for you, I won't be diving more into package modules or other, sophisticated features of object orientation here, but I'll talk about the generics like encapsulation, information hiding, object instantiation, instance methods, inheritance, and polymorphism. So let's start from defining object-oriented programming. For your information, I'm using Replit, a cloud platform that helps you to write different programs using different programming language. I've been using Replit for Java-related and Python-related practical, classes. So today the same will be true. I will be using Replit to show you the basics of object orientation, specifically in Python. So what does object orientation means? Okay, basically it's a programming paradigm. It's a programming paradigm. Okay, it's a programming paradigm. We call it object oriented design paradigm. It represents each state as each thing, each entity as state and behavior. Okay, so what does it mean? State basically means variables or their corresponding values, and when we say behavior, it means either instance methods. Okay, behaviors are either instance methods or class methods. So according to object-oriented programming, the paradigm believes everything is an object, and it can be represented or modeled, okay, as or modeled in terms of state, which are variables, and behavior, which are methods. Okay, which are methods. So basically, let's say we have any entity in this world. Let's say car. Let's say we have an entity called car. Okay, then the state for this entity could be, for instance, the make, the model, the year, the color, the CC, and every related informations could be mentioned as the state of this car. But when we come to the behavior of car, for instance, okay, for instance, you can drive a car, you can brake using the mechanisms in your car. There are different methods or behaviors that the car can do or that you can do using a car. So basically, object orientation means a way to represent something, in our case, car, in terms of state and behavior. Okay, so from the programming perspective, state means, as I already said, state means variables, behavior means methods. These methods could be instance methods or class methods. We'll talk about the difference between these two in detail. Let's start from classes. So when we see classes are basically they are general specifications of real-world entity. Okay, general specifications. What does it mean? We do not simply, we do not assign values to variables. Okay, variables, that's one thing. We just simply specify their domain. That's main difference. Domain, for instance, what does it mean? For instance, we might say x is type integer, but we may not we may not assign value to x. This is mainly in case of classes. Okay, so that's why we call it its general specification. Okay, so this is called class. Class is a general specification of real world entity. In our case, a general specification of car, a general specification of person, a general specification of house, a general specification of chair, window, table, everything is called class. Okay, so class again is constituted of two things. The first one is state, which is variable, and behavior, which is methods or method. Okay, so now let's see defining or specifying class in Python. How can we specify classes in Python? Let's take a class called car, for instance, since we have been talking about car so far. Let's take car. So from the state perspective, for instance, car, as we already mentioned, could have attributes like make, model, year, color, weight, length, width, height, and so far. So like so many other states, right? Variables. But when we see, for instance, behavior of a car, it could be drive, brake, park, reverse, gear, steer, or so many other behaviors or methods that you could do using a class called car uh, or the class called car could do. Okay, so in Python now we can define class as follows. Okay, we can define class as follows. We simply say, for the case of car, for instance, we say class car. Okay, we use here a colon, and since Python is indentation based, it's your IDE should automatically indent your next statement, but if it didn't, you have to indent it automatically. So this is a basic class specification. So this class, for instance, the above class, I mean, class is basically a blueprint, and it doesn't have any state. Okay, it doesn't have or has any state and behavior. Okay, explicit behaviors. It might have implicit behaviors, which are inherited from the general specification of a class in general, class module, but it doesn't have anything more. So this is a basic definition of a class in which nothing happens. Only the definition of the class car is done here, but no more specification is done here. So let me comment this one. The other option would be to define class with constructor. Okay, with constructor. Okay, class with constructor. What does it mean? For instance, in the previous case, we do have the class basically has default constructor. Okay, default constructor. Default constructor is a constructor that doesn't has state. Okay, we call it default constructor. So basically, constructor, is a place where you define your states or the state of the class. Okay, we call it constructor. So this is where we define the state of the class. So in the previous case, for instance, here class car, we have a class called car, which doesn't have an explicit constructor or a place where to define states. So for that purpose, we say this class car has implicit constructor, or we call it default constructor. Okay, default constructor. Default constructor. So default constructors doesn't have any state, but usually we have to define explicitly what states the class should constitute, or the class should be constituted of. So for that purpose, we have to use syntax to define explicit constructors in Python. So for that, I say class car, the previous definition, it's the same, but here I use init method, which is a method used to define the constructor for any class. Okay, constructor for any class. So here I say init. Init here holds number of states or variables that the class will use or will be characterized by. So here, this is basic specification of a sample class called car with a constructor. But as you can see here, this constructor has only one argument, which is called self. So basically, if you see self in any Python-related object-oriented programs, then self basically refers to the object, okay, which is the prospect object to be instantiated from this class specification in the future. So if you want to refer back to this object which is instantiated from the class car, then you use self. So this self's applicability here is also the same. Whenever this class or this method of this class wants to use this same class or instance of this class called object, then it uses self. Okay, so this is the default one, as you can see, in itself. For every object-oriented method, or we call it instance method, you have to define or you have to put self here. But since we have been discussing about the states of car, self is not the only state, self is just a reference. So we need to specify some more states. For instance, from the previous discussion, we said these are, the possible states of a given car. Okay, possible states of a given car. For instance, make of a car, model of a car, year of a car, color of a car, weight, length, width, height. This all describes what a car is, right? So here you have to use self. Okay, you have to use self and assign these arguments to the variables of the class itself or the object itself. Okay, so here this is the general specification, but this general specification should be copied to the instance variables called which are usually with the same name as the arguments, but with the self prefix, which states that these variables are instance variables, which belongs to every instantiated object. So we could do the same for all, like self dot model, self dot what is the next thing? The next one, year, okay, which is equal to year. We have another one which is color, self dot color is equal to color. We have another one called weight, self dot weight is equal to weight. Length is also the second one. The other one up to height. We have different arguments which defines what this class is, because we are specifying it under the constructor of the class. Okay, so here you have to copy whatever you accepted from the user to the instance variables of that same class or an object instantiated from the class. So this is how you define a class with state. So basically the above one, okay, the above class is basically is a class, okay, with state. Again, this class has state, as we can see here, around like 8 states, but it doesn't have behavior, which are methods. So you have to define a given class with both states and methods. So the place where to define the state of a class is called constructor. Here we already completed it, but in order to assign or in order to create methods for this class, we have to specify methods. So in the procedural paradigm, we have been discussing about functions. So the same type of structures will be used as instance methods for every class. So let me copy this one here, the definition of class car from the state perspective. And here I have class car. Okay, so this class car has around 8 states but no methods. So in order to assign method, you have to define a function which is called instance method. That means it should use at least one argument called self. So for that, for instance, the method that we could use for car, for instance, could be description, which describes what characteristics the car has. So for that, for instance, I could say print I am, something like this one. I am as this make, this model, and from this year, we could use this kind of description, or the car could display this kind of things for the user. For instance, assume the car has some kind of display, and whenever the user clicks on some button on that display, it might has to, display this information. So this characterizes the behavior of this sample class called car. So this is basically how we can specify real-world entities in object-oriented manner. That means in terms of behavior and method. I have used a simple method here. I can add some more methods, by the way, but I'm just using a simple method here for ease of pedagogy. Now, so far we have seen how we can define the class, the specification, both from the behavior and the state perspective. Now let's see how we can create objects from these specified classes. Mind you, we do have a class called car, which has this state, okay, around 8 states and 1 behavior, which is the purpose of this car is simply to display what it is. Okay, so assume its only behavior is description. So now let's create instances of this class. We call it objects that are usable, that are classes with variables that has value. Okay, so the way to instantiate objects is the same as the way you initialize variables, okay, in the previous class. So basically instantiation is the process of creating an object from a class specification. Okay, now let's use this class car to instantiate new type of car. So let's say I want to instantiate Yaris, a car type called Yaris 2023. Okay, let me define this one with these features. These features are car, which is the class type, and look, this corresponds to this one, this method, the init method. So the first explicit argument of this one, because this one is implicit argument of any instance method, including init. So we have to refer only from starting from the explicit features. Okay, so let's say we have the first one, which is make, in reality actually. So the make is Toyota. The second one is model. Model is Yaris. Year is 2000 something, 23. The color is white. I think the other one is weight. The length is some value. We do have also width and height. Let's say the width here is 3 meters, and the height is like 2.5. Sorry. Okay, say it's 2 meters. Okay, this is a process called instantiation. So assume this one is a variable. Here we are assigning values to this variable, but these values are composite values. That means values which are constituted of multiple heterogeneous primitive data types, or even sometimes it could be constituted of primitive and composite data types or objects. So in this case, I have instantiated an object called Yaris 2023 with states like Toyota, Yaris, like these ones. Okay, so this process is called instantiation, object instantiation. Now we have an object called Yaris 2023. So now let's see accessing the instance variables, okay, of objects. So in order to access the instance variables of objects, you simply use the resolution operator. For instance, I can say print Yaris 2023.make, which means an access mechanism to access the value of self.make, because the value of self.make is set here while instantiating the object. So this should absolutely give you the name Toyota when I run it. Okay, you see, this is how you can access variable, instance variable of any object. The other way would be to access instance method. So you can simply call the instance method by using the object name or as reference. Yaris 2023 dot description is the way to call this method. For instance, it should display this every information specified here. You see, I am Toyota Yaris from 2023 is displayed, since we have specified this kind of information here. So the correlation between this specification and this instantiation is reflected with this behavior. That's why we call methods are the behaviors of the class. We have already covered what instance methods are. For instance, in our case, this description is instance method. Okay, it's instance method. So instance methods are methods that belong to every instantiated object, or simply syntactically, these are methods which have self as an implicit argument for every definition of methods. So this kind of methods are called instance methods, basically. So we have seen what class is, how we can specify state and behavior. That means variables and methods, instance methods. Now let's see the unique and enticing feature of object orientation. So it's called inheritance. So inheritance is a mechanism where one class specification, we call it blueprint. We have been talking about that so far. So where one class or blueprint inherits the state and behavior, behavior of parent class. So it's a class that shows parent-child relationship. This is basically inherited from the normal, naturally intelligent or living things way of life. For instance, look, we might have, everybody has a father, okay, and the son inherits many things from his father, right? That's a reality. That's nature. So the son could inherit, for instance, what could the son inherit from, father? Let's say first thing, genetic composition, right? That could be one. You can dissect this one in different ways. The second one, for instance, like wealth, could be inherited from father. And under the previous one, for instance, characteristics, okay, appearance, even capabilities sometimes, right? Capabilities. Okay, in case of a wise father, it could also be discipline. Okay, how do you write discipline? Discipline, is it like this? Discipline, and everything else could be inherited from your father or mother, right? So this is a natural phenomenon. So object-oriented programming inherits this concept and tries to establish such kind of relationship. We call it generalization and specialization relationship. Okay, specialization and generalization relationships. So the moral behind this concept is there are many blueprints, I would say, okay, that has similar behavior. Okay, so in case of this kind of situation, you have to generalize and make a common base class base class or blueprint holding all common behaviors. Okay, that's one. The second one, in the case of the second one, there are some things, okay, the child does by himself or herself. Okay, this kind of things which cannot be done by the parent entity are specialized under, okay, under each child class. So inheritance basically is okay, inheritance is all about generalization and specialization. It's all about generalization and specialization. Okay, so let's see one example. For instance, let's see we have a class called car. Then there are different types of cars, by the way, right? We could have electric car, we could have hybrid car. Okay, different types of car could be categorized under the hypername called car. So for that purpose, we can say, for instance, electric car. Electric car. So electric car is kind of a child entity. Car is a parent entity, right? The reason behind this one is that car is basically, for instance, from what we know, car is a general entity, right? But when we say electric car, it's a special entity, because, you know, for instance, car. When you say car, there are cars that consume regular, like benzene. There are cars that use other types of gasoline. There are cars that consume electric directly. So we can say car is a general term, a general specification, which holds the common characteristics, or which resembles the common characteristics of the entity car. But we do also have specialized features of car which are resembled by, for instance, electric car or even hybrid car, right? So for that purpose, the relationship, the inheritance relationship, the generalization, specialization relationship between these two entities will be car as a parent, okay? And we have electric car, which is a child one. Why? Look, for instance, car, you can drive car, for instance, right? You can drive car. You can brake, you can park, you can reverse, you can steer, accelerate, decelerate, right? These all things are possible using every car, every type of, like any type of car. That's possible. So this, we can call them, these are general behaviors, okay? General behaviors. There are also general states of car, for instance. What are the general states of car, for instance? All those things that I have discussed so far. For instance, the you see here above, I think I discussed about this one already. So these are, for instance, the states every car should have, right? So look, the general state of car is make, model, year, color, weight, length, width, height. These are general characteristics. For instance, whether it is electric car or hybrid car or, you know, solar based car, it has make, it has model, it has year, color, weight, length, width, height, and, you know, some common features. So for that purpose, we say car, you know, car class could have all these states. And again, car class could have all these behaviors, like these behaviors. Okay? Then every other car that inherits from this car again inherits these states and this behavior. So now let's be specific, and let's try to write a code or inheritance relationship between electric car and normal generic cars. Okay, so first let's define the car. Let's define the car class, the main class. We call it parent class because it has some common features. So let's define it. Look here, I have defined class car that has this state and description behavior. Okay, let me delete this one because it's not relevant now. Now let's create again another car type, which is a child car. We call this one child class. Okay, so class, say electric car. Okay, electric car, and we use parentheses to specify inheritance relationship. So we say class electric car extends car class. Okay, which is the uh, the parent class. So basically, from what we have learned so far, I can simply instantiate, say, for instance, ID4 is a common electric car in Ethiopia, right? So let's say ID4 is electric car, Tesla Model S something, 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 like this. Okay, we can say it has these features, like 3 meter. What's left here? I think we're left with this 2 meter, I guess. Okay, so let's say we have ID4 object, which is instantiated from electric car. As you can see here, electric car doesn't have any constructor explicitly defined, but since it inherits from the parent class, then it automatically inherits the states and behavior of this one. So we haven't used car class here, but we only used electric car, which doesn't have any explicit constructor and method, but we can simply say, ID4, okay, dot description, and get some results that we could get by running the car class rather than electric car class. You see? So this is a concept of inheritance. Basically, it means using the characteristics, the behaviors, and the states of the parent class without doing anything. So this lays mainly or revolves mainly in the area of reusability. Okay, reusability, using something again and again without putting additional effort on it. Okay, so this is basically inheritance. But to give you some more additional concept, since the child class implements specialization, then it should have some characteristics which are unique to it. So for that, you can explicitly define the specialized methods for the special class or for the special um, child class. So for instance, refuel with electric could be, the only characteristics of electric cars. So for that, for instance, I might say print refueling with electricity. Okay, so this is basically how you implement specialization. So basically, this class, electric car, has two instance methods at this time. One explicitly defined refuel with electric method. The second one, inherited method, which is called description. So if I say ID4 dot refuel with electric, okay, which is a simple method, then in the second row here, you should see I am refueling with electricity next to I am a Tesla Model S from 2020. So here, this class, this method, this output is from the parent class, okay? But this second output is from the specialized method for the special class, electric car. So this is basically the essence of inheritance, okay? Inheritance. Inheriting the characteristics, the behavior and state of parent class, okay? So the other concept here would be polymorphism, okay? Polymorphism. So there are two types of polymorphism. The first one is dynamic and the second one is static. So usually we refer to static polymorphism as method overloading, okay? And dynamic polymorphism as method overriding. Method overloading and method overriding. So in case of method overloading. Okay, so basically method overloading, is a mechanism where we can have multiple methods with the same name but different behaviors. Okay, for instance, if I say, look here, for instance, in the electric car class, if I say def description, okay, def description, look here, and if I say print like this, this is a description from, this is a description from electric car class. Okay, if I say so, for instance, then this would be overloading the behavior of the parent class method, which is description. So if I say now id for dot description, which is the object of the special class, the child class, then it won't display, I am a Tesla Model S from 2022. It simply says this is a description from electric car. So let's check here. You see, it says this is a description from electric car class, rather than I am Tesla model Model S from 2022. This is mainly due to the fact that we have overloaded the method description under the class electric car, which is the class that inherits from the main one. The other concept, this one basically is called static polymorphism. Okay, static polymorphism. By the way, polymorphism means simply it's a combination of poly and morph. Poly is multi, morph is shape. So it's about using the same thing in different shape, okay, in different manner. So here we are using description method in different manner here, which is different from the manner we have been using in the parent class. The other one is method overriding or dynamic polymorphism or method overriding. Okay, so when we see method overriding or dynamic polymorphism, it's it's a way to modify the signature of the method itself. Okay, method override basically helps you to override the method signature and also the behavior of the method. So it's a method or a mechanism where we can have one method with the same name, okay, with the same name as the method of the parent class, but with different behaviors, okay, but with different behaviors. Let's see one. Let's add one more method so that we can override it later. So let's add one more method inside the parent class car. Let's add one method called def. Let's say roll. Okay, let's say def roll, and let's say it has something called some mechanism to show how it roars, the non-electric for the non-electric or for the generic car. It might be like I am a car that roars loudly, say. Okay, let it be the method of this one, and let's override this one by keeping the name but changing the signature. The signature of any method are these arguments here. The return type, there could be referred to as signature. So we have a roar method under the main class, which is inherited by the child class electric car. Now let's override this one under dynamic polymorphism section. So I say diff roar, okay, like this. I use self, the same as the previous one, but let me add one argument called sound, okay? And again here, let me add some characteristics. Okay, I might say I am a car that doesn't, okay, roar loudly. This is the characteristics of electric cars, right? So here, for instance, when you use the previous class, for instance, the previous methods, for instance, look, sorry. So if we use the previous instantiation, ID4 electric car, something like that one, if we display ID4.description, you will get the description method which is overloaded under the electric car. By the way, we say overloaded because we haven't changed the arguments here, the return type here. Everything is the same, but the concept, like the message is different. Something is overridden if its signature is changed. So if you see the roar method here, in the previous one, it has only one implicit argument, which is self, but in the child class, it has additional argument called sound. So here we can, for instance, look, add the sound here, for instance, like this, okay? So that it can be displayed to the user. So let's go back to the instantiation. We have instantiated ID4. We have called ID4.description for the what we called for the child class. We have ID4.roar, a new one. So let's say the argument for sound is silence. Okay. And again, we have another method called with ID4, refuel with electric. Okay. So this basically is all about calling methods, both parent methods or child methods, or calling overloaded methods or overridden methods using the object instance. Also, let's instantiate object for the parent one. So let's say general car, okay, and let's instantiate general car by using the constructor for the car method. Okay, so for the car method, for instance, we do have different constructors, different states. So here I am assigning for the weight, for the length, for the weight, width, and height. So now we have this one. If I call, for instance, general car dot description, you wouldn't see the result that you get when you call ID4.description. You see only the the behavior of the parent class, which is car. So if I call, for instance, general car.description, I see this message. Okay, this message. If I call ID4.description, I see this message. Okay, because it's specialized and overloaded here. If I call, for instance, ID like general car dot roar, I see this message like I'm a car that roars loudly. If I say general car dot roar, sorry, ID4 dot roar, I see the message from the electric car category, which is I'm a car that doesn't roar loudly, like silence. Okay, if you provide it silence argument. So let's do that. Let's call it with general car roar. Okay. And the last one is I think we do not have another method for the parent class, right? So only we do have two methods. So let's run this one. Let me clear this one for ease of readability, and let me rerun it. Look, for the first one, this one, ID4.description. This is a description from electric car class. That means this ID4 is instance of the child class, so it calls for overloaded method called description rather than the main method in the main or in the parent class. The same is true for the second one. ID4.roar simply says I am a car that doesn't roar loudly and silence. That means it's a method which is overridden here in the child class. Okay, the message that we get when we apply or when we call the parent method is different from this one. And the last one is refueling with electricity, which belongs to the call that we made for ID4.refuel with electric, which is a child class unique or special method. as you can see, because we do not have this kind of method on the parent class. And the other one here is a call from the parent class. So here, for instance, I am a Toyota Yaris from 2013 is a method which belongs to the parent class. General car is an object of the parent class. So you see, not this one, the behavior of the child class, but the behavior of the parent class, like pertinent to this function. Okay, the same is true for general car dot roar. We see the characteristics of general cars, not the characteristics of the parent, sorry, the child cars. That's all about object orientation at glance. You have to dig more, you have to read more, you have to practice more with exercises from internationally reputable websites, platforms. But for now, since my plan has been to show you how you can represent things in object-oriented manner using Python, and how you can get to know the basic concepts of object orientation, this would be enough for you to start, dealing with object orientation. Thank you.